Math is a pretty important subject.
Hi class, it's Mr. Robinson. Glad you clicked on this video. You gotta love math. Hey, it's Mr. Robinson's look at trig, the infamous trigonometry.
Sakatoa, baby!
And my world is love.
Hi class, glad you clicked on the video and are looking at problem solving using trigonometric ratios. When we learn something like trig, we can apply it to many different things. Up here, this is just an idea of what we could have in a trigonometric function. So we have maybe like, a tree here, or a building, or people, and that's often, we have to find the height of something. Here we would have maybe, like a string or a ladder leaning up against the wall, or some kind of tunnel. And then down here we often see things like shadows. And so we always build a nice right angle triangle so that we can figure these things out. So here we have class exercise 1. Take a look at Carmen. Carmen is using a transit. It's this thing right here, and it determines angles. And so Carmen is trying to figure out the height of the tree to the nearest tenth of a meter. All right, so go ahead and figure that out. Plus, you're going to have to use that height of the tree right here to answer the angle that the base of the transit makes with the top of the tree. You're going to have to rewrite another right angle triangle. All right, so hopefully you can use this information to answer that question. Go for it. Class exercise number 1. Press pause now. All right, well, Carmen's a pretty smart surveyor, and so Carmen finds that the fact that the transit stands 1.8 meters high, okay? So there's a 1.8 meter distance right here, okay? So when we find out the height of the tree, we're going to have to add this 1.8 meters in there to get the exact height. And that's okay, because Carmen knows about these things, and Carmen's going to do that. Hopefully you did it as well. So we have an opposite here, okay, and we have the adjacent here. Because we have the opposite and the adjacent, we're thinking TOA here. So the tan of 12 degrees equals the opposite, whatever that is, the height of the tree, over the adjacent, which is 52, and that's meters. All right, so we throw that into a calculator after we cross multiply. So we see that we have O equals tan 12 degrees times 52. All right, we throw that into a calculator, and you're going to get that the opposite equals 11.1 meters. So that's this distance right here. It's 11.1. We have to add the 1.8 to it. So 11.1 plus 1.8 equals 12.9 meters. And that is the height of the tree. Okay, circle my answer, 12.9 meters. Now I can use that to find this angle here. We're going back to finding the angle, but in this case we have now a correct height of the tree. It's 12.9 meters, and we want to find the angle to the base of the transit. So remember, the transit is right here, all right, and we're finding the angle to the base of it. So it's still 52 meters here, okay? And so we have x degrees. We don't know what it is, but we do have the opposite and we have the adjacent. In that case, we would say tan x degrees equals 12.9 over 52, okay? So we put in our calculator 12.9 divided by 52, then we inverse tan to get that. And so x degrees equals 14 degrees. And so the angle equals 14 degrees. All right, here we have another problem. It's a circle with center C, okay? Radius is 20 millimeters, okay? And so I'd like you to try to determine the length of OC to the nearest millimeter. Go for it. Well, we're doing trig, so we know that we have to find a right angle triangle. Okay, we're trying to find this distance right here. Okay, and so where can we make this right angle triangle? Well, we can make it right here. Okay, and we're trying to find OC here. Well, interestingly enough, this is our radius. Okay, so we already know that the distance between the center of the circle and here is 20 millimeters. We also know that because C is right in the middle, that this is 25 degrees and this is 25 degrees. So that makes 50 degrees. So now we have an opposite and we have an angle, and we're trying to find the hypotenuse right here. So we know that it is sine equals opposite over hypotenuse. All right, well, what is our opposite? Well, it's 20. So the sine of 25 degrees equals 20 over OC. We can switch those around, okay? So OC equals 20 over sine 25 degrees. And we know that we can switch these because when you think about it, like let's say 10, 5, 2, okay? You could switch these 5 to 10. So in this case, 2 equals 10 over 5. In this case, 5 equals 10 over 2. It's just a property of math that you can switch these here. So we've done that. All right, now we have the OC equals 20 over sine 25 degrees. We throw in our calculator 20 divided by sine 25, and that equals 47.3. Okay, so if we're determining to the nearest millimeter, OC equals 47 millimeters. Now I'm going to skip class exercise number 3, and I'm going to talk about class exercise number 4, but first I want to tell you about bearings. Bearings is a pretty easy concept. It is just basically an angle from the direction of north. So in this case, we go from north 40 degrees, and that is the boat's bearing heading in this direction. So this one we see here, that's 150 degrees. We can have a bearing of 225, so they're going this way. So that one is 225 degrees. And here they can almost go all the way to 360, and so this is a 330 degree bearing right here. So we can use bearings now to do a word problem. So in this case, we have a boat at point P and starts heading toward Q. Okay? Now, when it gets to Q, it turns and heads right up here, okay, at a point east of point P. Okay? So they want you to find out how far east of P is the ship when it's at position R, which is right here. Okay? Now I'll give you a couple of hints. The bearing was 120 degrees. We know that this is a 90 degree angle. So if this is 90 degrees, then this would be 120 degrees. Take away 90 degrees. So that's going to be 30 degrees right here. Okay, so we have some degrees. We also know that we have this right here, which is the 6 kilometers from P port. Okay, so if the ship goes 6 kilometers, now we have a side, we have an angle, we should be able to figure out everything. And you are trying to figure out A, this adjacent angle. So that would be adjacent over hypotenuse. You're going to need the cosine of 30 degrees to be involved in this calculation. All right, We've got A over H, which is 6 kilometers. Why don't you try to figure that out? Go ahead. Okay, we're back. So cos 30 equals something over 6 degrees, and that is this line here, PR. All right? We know that we can multiply both sides by 6. Okay? There's an equals in there. And so these cancel out. And so now we have side PR equals 6 kilometers times cosine 30 degrees. So we throw that into the calculator. We're going to type 30. We're going to hit cosine. We're going to multiply that by 6. And we get 5.19. We want to round it off to 5.2. So PR, side PR equals 5.2 kilometers east of P. So now we know that A here, this adjacent side, is 5.2 kilometers. I'm just going to write that in because we need more space for the next activity, which says that the ship continues traveling north for a further 12 kilometers to a position of S. Travels north a further 12 km at position S. Okay? Determine the bearing of S from P. Okay, what's the bearing? Well, in this case, remember, bearing is from north to whatever that is. Well, we don't have much of an angle to talk about here. We don't know what is up here. So the only angle that we can talk about is this, but that's okay because this plus this makes 90. So if we can find out this, then we can find out this because we take it away from 90 degrees. The distance here is 5.2 kilometers, and over here we have 12 kilometers. So in this case, because we have this as the angle that we're looking for, this is our opposite, this is our adjacent, we can use the tangent. Okay, so the tangent of x degrees equals our opposite, which is 12, over our adjacent, which is 5.2. Let's throw that in the calculator. 12 divided by 5.2 equals that, and then we're going to put the inverse tangent, and that is 66 degrees. All right? Now that's not finished. Okay? So if we have this, which is 67 degrees, it's 66.5, then we know that this angle here is going to be 90 minus 67 degrees. So that is going to be 23 degrees. All right? So the bearing equals 23 degrees. Now finally, if the ship maintains an average speed of 9 kilometers an hour throughout the journey, determine to the nearest tenth of an hour the time taken for the journey. All right? Well, we have this and we have this, but we still need to figure out RQ to figure out how long that is. Well, we have a bunch of figures. Why don't we just throw in sine 30 degrees equals RQ over 6, which is this 6 right here. Okay, so RQ over 6, which means that RQ equals 6 times sine 30 degrees. Throw that in the calculator. 30, the sine of that, times 6 equals 3. So RQ equals 3, and it's all kilometers. Okay, so now we have 3 kilometers. It's getting kind of messy, so I'm going to rewrite this. It goes 6 kilometers, then 3 kilometers, and then another 12 kilometers. So we add these all up. 6 plus 3 is 9, plus 12 is 21 kilometers. So they've gone 21 kilometers. Time equals distance over speed. Okay, so that is 21 divided by 9 kilometers an hour. Okay, and that equals 2.33. Okay, all right, and we were asked for the nearest tenth of an hour equals 2.3 hours. And there you have it. That is the end of Trig lesson number 6, looking at problem solving. Hope you enjoyed it.